Hello everyone, I am Afreen and today I am going to say about insertion and deletion in binary search tree. Before going to say that, let us discuss some rules of BST, that means binary search tree. So let's see the rules. The first rule is each node has up to 2 children in binary search tree. Left child has a value smaller than the parent node. Right child has a value larger than the parent node. And in binary search tree, there is no duplicate elements allowed in it. The left and right subtrees of any node also follow these same rules. So first, these are the rules. With the help of these rules, let us discuss insertion and also deletion in BST. So first, let us see about the insertion in BST. So let us see the example for insertion. So as I said above rules, we need to follow that rules and we should do the insertion process. So first, the first element is the root node, let us take, or parent node. And after, this is a parent node or root node something, and the second element is 6. So what is the relation between 6 and 11? It is 11 is greater than 6. So it should be inserted left of the parent node. See the first rule. And after, the second element is to insert 8. 8 is less than 11 and it is greater than 8. If element is greater than the root node, we should insert in right side. The next element is 19. 19 is greater than 11. So it should be inserted right to, and it is also less than 6. So it should be placed here. And 10. 10 is less than 11 and 10 is greater than 6. 10 is greater than 8. So it should be inserted here. And 5. The element 5 is less than 5. So it should go left side, and less than 6 left side, and it is greater than 4. So it should be placed right side of the 4. And element 17. 17 is greater than 11 and less than 19. So it should be placed here. And 43. 43 is greater than 11 and it is also greater than 19. So it should be placed here. Next element is 49. 49 is greater than 19 and it is also greater than 43. So it should be placed right side of the 43. The last element is 31. So here 31 is greater than 11 and it is greater than 19. It is less than 43. So it should be placed left side of the 43. So this is the final tree after the insertion of BST. This is the process and the construction rules that we follow. And so the next step is deletion. So let us discuss about deletion process step by step. So in deletion we have 3 rules. That is, first one 0 child deletion, and second one is 1 child deletion, and third one is 2 child deletion. Here for 0 child means that is leaf node. In take this example only. In this 31 and 49 are the leaf nodes. That means there is no extra node connected to this. 2 childs. So in this 31 and 49 are the leaf nodes. So leaf node is directly disconnected from the parent node. That means the 43 is leave there and it was free from 43, and here there is no node. So 31 is directly deleted and it is free from this tree. And for 1 child, that means let us see this one 4 5. Here there is 1 child for 4, that is right child. So 4 is replaced by 5. If we want to delete 4, suppose delete 4, then 5 should replace the 4 position of 4 and 5 directly eliminated, and this 4 will converted as 5. So like that we can delete for 0 child and 1 child in this way. And for 2 childs we have 2 rules again. For two child, we have in order, predecessor, and the second one is in order, successor. So we have these two ways to solve for two childs. Um, let us delete 11. For example, to delete 11, 11 has two childs. So we need to use in order predecessor or in order successor in this case. So how can we use this? In order predecessor, it means the maximum element, that means highest element in the left, maximum element in left subtree, highest element in left subtree. So this is the left subtree. So in this tree subtree, the highest element. So what is the highest element in this? 10. So let us replace 10 with 11 and we should do the tree. So I am writing here again. 10 is replaced in 11. 11 is going to be deleted. And tree is as it is, as before. So just we need to leave this 10 from the tree and replace in 11. This is how we should do the in order predecessor. And in order successor, the next step is in order successor. That means this have two steps, right? So we completed first one, and in order successor means the next to the root, the what is the next of it? This one. In right subtree, we should check. In right subtree, the minimum we need to take. That means less. What is the less in this? 17. 17 is less, root. So let's take 17 and replace 17 with 11 in this in order successor. So what should we need to do to delete 11? Place 17 in this 11 as it is smaller in right subtree, and write left subtree as it is. Just leave the 17. Leave the 17 from this right subtree and add the 17 to the root node. And this is how we need to do deletion in BST. This is the process. So this is the insertion and the final output is this. We can take any of this, no problem. And our friend will continue the next.
I am right. I am discussing how to find height of any node in BST. The height of a node in the binary search tree is defined as the number of edges on the longest path from that node to a leaf node. A leaf node has a height of 0 because there are no edges beneath it. Now let us take an example of binary search tree. Now we want to find the height of all the nodes. For example, let us take at node 5. At node 5, it is a leaf node. It has no edges. So the height of the node 5 is 0. In the same way, the height of 10, 31, 49 is 0 because it has no edges. Now let us take the node 4. The longest part from the node 4 is 5. It has one edge. So the height of the node 4 is 1. In the similar way, the height of node 8 is 1. Node 43 is also 1 because it has only one. So 43 has one edge. So the height of 43 is 1. Now let us take node 6. The longest part from node 6 is 5 or 10. It has two edges. So the height of 6 is 2. Similarly for node 19, the longest part from node 19 is 49 or 31. It has two edges. So the height of 19 is 2. Now similarly for 11, the longest part for the 11 is 49, 31, 10 or 5. It has 4 edges. It has 3 edges. So the height of 11 is 3. In this way, we should find the height of a node in BST. Now we are going to discuss about the level of a node in binary search tree. The level of a node in binary search tree is the number of edges from the root node to the given node. Now let us take the example in binary search tree. The level of a node in binary search tree is the number of edges from the root node to the given node. For finding level, there are two rules. One is root node and other node. The level of root node is 0, and the level of node is 1 plus to the level of its parent node. Now let us take node 11. Since it is parent node, the level of root 11 is 0. Now let us take node 6 and node 19. The parent nodes of node 6 and node 19 are 11. The level of level is 0. So we should add plus 1 for finding the node level of 6 and 19. So the level of 6 and 19 is 0 plus 1, that is 1. Now for finding the level of node 4 and node 8, node 17 and node 43. The parent node of node 4 and 8 is 6, node 17 and 43 is 19. The level of node 6 and 19 is 1. So finding the level of node 4, node 8, node 17, 43, we should add plus 1, that is 2. Now for finding the level of node 5, node 10, node 31, node 49. The parent nodes of node 5 is 4, node 10 is 8, node 31 is 43 and node 49 is 43. The level of node 4, node 8, node 17, node 43 is 2. So finding the level of node 5, node 10, node 31, node 49 is, we should add plus 1 to 2. So 2 plus 1 is 3. So now final levels are, for node 11 it is 0, for node 6 and node 19 it is 1, for node 4, 8, 17, 43 it's 2, for node 5, 10, 31, 49 it's 3. In this way we can find the level of any node in BST.
I am Sahifa. I am going to discuss about how to find whether the node is leaf node or not. Consider this example. Now take 5. Check whether it has a left subtree. If it equals to none, then check right subtree. If right subtree equals to none, then we consider it is as a leaf node. In this example, the leaf nodes are 5, 10, 31 and 49 and 17. So next topic is searching. Consider an example now. Now in this example, if we want to search an element, consider if key is equals to 11. Now here first check 11 with the root node. Now root node is equals to 11. So key is equals to root node. So we have find the key. We are searching. Now if we want to search for element 4, consider key is equals to 4. So first compare with the root node. If root node is less than the key, then check in the left subtree. Compare with the root node. Root node is 11. The key element we are going to search is 4. Now 4 is less than 11. Now we have to search our element in left subtree. Now compare with 6. 4 is less than 6. Now again search in left subtree of 6. Now compare with the 4. Now 4 is equals to 4. There we find our searching element. If we want to search for 43, then we have to look in right subtree, because 11 we are going to search 43 is greater than 11. Now search in right subtree. Now compare with the 19. 19 is greater than 11. So now again search for right subtree. Now 43 is equals to 43. There we find our searching element. We have three conditions, like if the key element is root, then we will element is found. If key is less than root, then we need to search in left subtree. If key element is greater than root, then we have to search in right subtree. This process is repeated until the key element is found. So these are the few operations that we perform on BST. Thank you.